Okay, so we are going to do an introduction to geometry today. We're going to start by looking at angles. There's two types of angles that I want to work with you on today. Very important both for foundation and higher, actually. Angles in parallel lines and angles in polygons. Okay, so these pop up in exams all the time in lots of different formats. One form that they do, so in foundation, they tend to be more kind of focusing on just on finding the angles and those things. In higher, we do get these combination of algebra within those angle questions. So I will try and do some of those at the end for higher tier students. And also, I think if you're doing foundation, they would be just a really good way of seeing how, you know, those equations that you're learning how to solve, you can actually form them from these kind of questions as well. So we'll do that. We'll do some skill-based stuff and then hopefully have time at the end to do some exam-style questions. I want to start on just a really basic angles task. So we're going to look at this. It's going to be a bit interactive. I'm going to ask you to either speak out loud or pop in the chat for me some answers to these questions. So looking at these two triangles, can anyone tell me, bonus points if you can spell it, what are these triangles? What kind of triangle are they? Pop in the chat for me, if you can do that. Excellent, well done, isosceles, well done, brilliant. Okay, so yeah, two isosceles triangles here. And that means, and this is one of those phrases that you need to commit to memory, what is special, not just that the sides are the same, we've got the two equal sides there that you can see, these dashes on them tell us that the sides are equal, but what does it tell us about the angles? What do we know about angles in isosceles triangles? Equal, fabulous, okay. Two angles are equal. And one of those commit to memory phrases is that the base angles in isosceles triangles are equal. So it's the two at the base of the equal side of the same size sides. That's hard to say. That are the equal angles there. Okay. So we know then that A and B must be equal. What angle factor am I going to use to calculate what A and B are then? What do these three angles add up to? 180. Fabulous. I've got some really great answers. Thank you for this. So we know that these add up to 180. Okay. We know that they are the same. If you want to do it and have a go, and if you've got your calculator handy, if not, do a little bit of maths. Tell me what A and B are. I'm going to answer it just behind you. Brilliant. Fabulous. Really, really fast, really really quickly answered there as well. So we've got the answer 68 for A and B. I'm going to put those in there. Brilliant. Now, one thing that I just want to do, because you know how I love this, is just show you how you could have done that using algebra. So we could have said that A equals B. So we could therefore say that this angle is A and so is this angle. Okay. So now we know that we've got A plus 44 is equal to 180, because if we add those three angles up, then we know that they're going to be 180. Now from our algebra skills, we know that A plus A is just 2A. So we've got 2A plus 44 is 180. And you can see there that what we've done is we've formed an equation, which we could then solve to get the answer 68. Okay, so I would subtract 44 from both sides. And then, okay, and then I would divide by 2. Okay, so I would get the answer 68 from doing that. Let me clear that. Okay, so it's a good idea just to kind of get that for a feel, because we'll be doing a lot of that in exam style questions later. So who can tell me then what C and D are? Let's move on. Brilliant. Well done. Okay. Thank you, Mary. Correct. So C and D are 68. Well done. Now, what is this angle in the middle, E, going to be? Calculations going on 44. Fabulous. Well done. Two ways of doing that. I'm going to talk about both ways of doing that in just a moment. And finally, just on its own there, what is this angle F going to be? So what we need to do here is we need to know what this is. So this is a right angle, which means it's 90 degrees. Okay, so spotting that, we can now add those up and subtract from 180. Got you all doing lots of adding and subtracting today. Nice one. Brilliant. 31. Well done. Okay, so that's just kind of a little warm up there. So you've got all of those correct. And I just wanted to come back to this one because this one is 44. Now you'll notice that this is the same as this. Okay, so you'll notice that those are the same. Now, you might then be able to tell me something about these lines. Can anyone tell me from that information something about these two red lines I've just drawn there? And if not, don't worry. Yeah, brilliant. They're parallel. Okay, well done. So by knowing that those two angles are the same, we know that those are parallel lines. Okay, so that's really great. I'm just going to quickly go through all those angle facts with you. So let me clear that. So what we've used is we know that angles at a point add up to 360 degrees. Okay, so we could say A, B, C, and D, they add up to 360. And you've also just used this quite a lot. This angles on a straight line add up to 180. Okay, we also used the angles in a triangle add up to 180. Now, these angles, there's something special about these. If you've got two straight lines that cross over like this, so a little bit different to what we had before, because what we had before, those lines weren't crossing directly over, so we couldn't use this. As you see, those lines were stopping there and then changing there. We couldn't use this, but if you do get two lines that cross over, what you get is this double set of angles. Does anyone know what they're called? They've got a special name and you have to learn that name and you have to be able to use that in your exams. It's got two words and it's quite easy to remember because you just look at their orientation to each other, look at how they are sort of located. Think about A is what to A and B is what to B, and then that's the word that you need to use. That's one of the words. First word starts with V. Second word starts with O. Don't worry if you've not heard it, that's fine. I'll put it up on the screen now for you. So vertically opposite angles are equal. Now write that word down, or those words down. Vertically opposite angles. One of the things about learning angles is that you pretty much always have to give your reasons in the exams as well as just finding the angles, or not pretty much always, but quite often. So quite often you won't just be asked to find a missing angle, but you'll be asked to give a reason for the missing angle that you've found. So if I tell you that this one here is 120, you should be able to tell me all of the rest of these angles, okay? Because vertically opposite angles are equal. So I know that this one here is 120. But giving the angle itself is only going to get you 1 mark in the exam. The second mark will be from writing down this statement: vertically opposite angles are equal. And that's really useful. In angles in parallel lines problems, that is a really, really useful thing. Okay, so make sure you've got that written down and then commit it to memory before you do go into your exam. Okay. Now, the other thing you'll notice is that they're on a straight line. I've got this straight line going right through here. So that means that B and A are equal to 180. So I can calculate what B is as well. If A is 120, I know that B is 60. And also there's another straight line here. So 180 minus 120 is 60. And that shows you that these ones are also equal. So that's just a little proof there for vertically opposite angles are equal. And that's going to be really useful as you go through your angles work. Okay, so remember that one for me. And we're going to now look at what happens when a straight line crosses over 2 parallel lines. So instead of 1, 2. I've got something missing here. very bad form. Parallel lines should have arrows on them to show that they are parallel. Okay, so I should have drawn arrows on those. I apologize for that. If there are no arrows on the parallel lines in your exam, you should not assume that they are parallel. Okay, so you cannot just, unless you're told in the exam that they're parallel, or if you see the arrows on them like that, then you know they're parallel. Okay, but if you don't get that, then you should not just assume that they're parallel. Okay, you may be asked to prove that they're parallel, in which case you can use this fact that we're learning now. Okay, which is that 8 angles are formed. When you've got, obviously, when one line crosses another line, you've got 4 angles, but if a line crosses 2 lines, you've got 8 angles. Okay, so we've got these 8 angles here. But once again, we only actually get 2 different angles in these 8. Of these 8 angles, only actually 2 different numbers. And just another bit of vocab for you, a line that crosses a pair of parallel lines is called a transverse. Nice thing to know, you might see it in the exam, but you're not generally asked to remember and like repeat that word. But vertically opposite, you might have to actually remember that and write that down. Okay, so it's a word for learning. Now, we've got 8 angles that are formed, but actually only 2 different angles. Really, really easy. I'm going to go through all these proofs, but it's really easy. Basically, if this A is 1, I'm going to go 120 again, because we've just done that. Then because of vertically opposite angles, then C is 120. And then I'm going to show you later reasoning for this, but also this and this are going to be the same because they're parallel. It's essentially, you can just imagine sliding this line down here and it would be exactly the same line there. Okay, it's just sliding it up. So you've got this exactly the same line, essentially. So all the angles are exactly the same. And that means that this then is going to be 60. So this will be 60. So this will be 60. And this will be 60. Okay, so even though there's 8 angles, there's only actually 1 pair of angles, and then they're just repeated all the way through. And they've got that lovely diagonal thing going on there, okay? So parallel lines are actually very easy to prove that they're parallel because you're just looking to show those are equal, that's the same as that. If you can just show that, then you can pretty much prove that they're equal. The tricky thing with parallel lines is remembering all of the correct vocabulary, because you're not just asked to prove by showing the angles, but you're normally asked to write down all the vocabulary that goes with it. So remembering those vocabulary, we have got corresponding angles, okay? Corresponding angles are the ones, my students and I used to say they were the ones that were like under the armpits of the parallel lines, okay? So you've got these ones here, okay? So if they make what looks like an F shape, if you can see that big orange F there, okay, if you can see that shape, we call them F angles because that's the shape that they make. But they're actually called corresponding angles. And in the exam, you must write down the words corresponding. You cannot write down F angles. You will not get any marks for that, okay? So although it's quite useful just to remember, do not write that down in the exam. You must write this word down here. So that's what you need to remember, okay? So corresponding angles, there are 4 pairs of corresponding angles on one of these transverses. They will be D and H there, as you can see under the F. They will be A and C, so those are equal because they're corresponding. We've got C and G, those are equal because they're corresponding. And we've got B and F there. So we can see the F shape has just moved around. It's always an F shape, it's just sometimes upside down or backwards. Okay, and there are all your corresponding angles. Next one is alternate angles. And again, they make a Z shape, but they are actually called alternate. So you can remember sort of the A to Z, alternate to Z. But again, in your exam, make sure you write down alternate. Do not write down Z angles or zangles, as some people call them. You won't get any marks for zangles, okay? So it must be written down. You must write down alternate angles if you are using alternate angles are equal as a reason. There are two pairs. So you can see this Z shape here, which gives, so that D and F are equal. And then this sort of backwards Z shape, C and E are equal. So the alternate angles are those ones that make those Z shaped ones, okay? And finally, the last one is, they're called co-interior, or some people call them allied angles. What do you prefer, Tabitha? Do you have a preference, co-interior or allied? What have you heard before? Oh, hello, we've got someone else. Thank you for joining us. Co-interior, brilliant. Okay, so same, that's what I tend to teach as well. If you see allied, it's exactly the same thing. We just have two words for it, okay? I think allied is more sort of international, used in America, whereas co-interior is a bit more British. But apart from that, exactly, they mean the same thing. And they're slightly different because they add up to 180. They're the ones on the inside, okay? So very easy to prove, because this one here, well, we've got the corresponding angle down here, which is going to be the same. We've just learned that corresponding angles are equal, and they're on a straight line. So it's 180 minus 40. 140 gives us this 40. So basically, the interior, co-interior angles in parallel lines add up to 180 degrees. And so we can use that fact as well. Okay. And so we've got two sets of co-interior angles on both sides, but kind of inside. Also, some people use the C angle. Okay. Once again, do not write that down, and you won't get any marks for writing that in the exam. You must actually write the word co-interior or allied. You can get marks for either of those. Okay. Some people like teach other words. You won't get marks if you just write down interior, because interior could be for, say, in a polygon. We'll do that soon. And you won't get marks if you write down supplementary. Supplementary is the word for angles that add up to 180 degrees, but it could mean anything. So these two are supplementary because they add up to 180. These two are supplementary because they add up to 180, but their special word for parallel lines is co-interior or allied, okay? So just be careful with the vocab for that one. And let's move on and do some actual, it's enough information for now. So there's all your information. Hope you've written down those words. I hope you've got them in your memory, because it is time to do some A, B, C, D. So I would like you to have a look. We're going to move through this one quite quickly. I'd like you to have a look at these angles and then decide for me if they are A, alternate, B, co-interior, C, corresponding, or D, vertically opposite. And I'm going to let you choose from A, B, C, or D now. Someone's gone in very quickly with an answer. Oh, two people. See if we can get some more answers in. Brilliant. I'll give you another 4 seconds. Brilliant. Okay, well done. Everybody's gone for alternate, and you are all correct. So the answer was A, alternate angles. Well done. I'm going to speed things up now. Okay. How do I, oh, there we go. So next ones, are they A, alternate, B, co-interior, C, corresponding, or D, vertically opposite? Cast your votes now. Great. Just 2 more seconds. And time's up. Brilliant. Well done. We've got all of you saying corresponding. Corresponding is correct. Well done. We're getting 100% on this, so we can go really quickly. Speed things up again. Okay, having a look at these ones, we have got, are they A, B, C, or D? Cast your votes. I'm wondering if, oh yeah. Okay, so they are both inside and they're on the same side, okay? So they are the co-interior angles. So I'm just going to quickly show you that they actually make what's called a C shape, okay? You can see the C shape there, and they are the ones that add up to 180 degrees. So they are called co-interior angles. And so the correct answer there was B, okay? So well done. Let's do one. Oh, wait, I need to give you another question, don't I? There you go. Okay, here's another one. Have a go. I'm going to give you a second to look at it before. Are those angles alternate, co-interior, corresponding, or vertically opposite? Have a look. What shape do they make? Can you remember those words? And have a go for me. Don't know if that's worked. Oh, there we go. Okay. Oh, we've got some split decisions. Just give you another couple of seconds to answer. There's a couple of people not answered. Okay, I'm going to end it there. We're going to just talk through it because we've got some split decisions. So they are making the Z shape, okay? So the easy way to remember this is that the Z shape, they're on alternate sides. They're the only one where they're on alternate sides of the transverse of the line there is the one called alternate angles, okay? So if you have to kind of think, oh, one's on that side and one's on that side, that's the alternate angle, okay? So that's an easy way to remember that one. So the correct answer there was A. Ooh, computer's just freezing on me a second. There we go. And it all back. Oh, I've given you the answer. I'm sorry. There we go. That was the vertically opposite one. You can see that they are the directly opposite each other. Apologies. Here's another one. I won't give you the answer for that. Oh, someone's gone straight. Oh, brilliant. Straight in with the correct answer there. Okay. Well done. Very good. So we have got corresponding. So corresponding angles, I know that you know that one because you're getting those correct. So they are both on the same side and they make that F shape. You can see if you imagine highlighting around those angles, they would create an F shape. I think we talked about this before, didn't we? And we decided, I don't think you can actually take highlighters in the exam, but I need to check. But you can definitely get your pencil and draw around the angles and see that shape. Okay, so it creates that F shape there. So you can see that they are corresponding angles. Okay. One more, I think this is the last one. Just turned it around to show you that they're not always going to be in the same direction. Okay, so what shape angles are they making? Oh, quick. Well done. Okay. Almost all of you have taken part. I'll give you another second. And well done. Brilliant. Okay, so even though I've turned it around, you could still see that they are the corresponding angles. They're still making those F shapes there. Okay, 1, 2. We join that up there. We've got that. It's a sort of on its side, upside down F shape, but it's still an F shape there. Okay, so they were corresponding angles as well. Oh, there's one more there. I think we've done enough now though. So there we go. So we did say we'd have a look at some past exam questions. So we'll talk through this question. One of the main reasons why I wanted to, oh, let me get rid of the, is the poll in your way? No, can you see the screen okay? Okay, good. Okay, brilliant. So let's talk through this past exam question. So one of the main reasons I wanted to do this, just to show you the notation here, when exams are talking about shapes, they name them, and they name them according to the letters at the vertices, or which is just another word for corners of the shape. So this parallelogram is called ABCD because its letters at its corners are A, B, C, and D. All right, so that's how you name the shape. So if you see that, don't be put off. It's just literally talking about the shape from A, B to C to D. And then the angles they also name, and the angles they name, the one in the middle, the letter in the middle, is where the angle is. So you can always imagine sort of starting at the first letter, going to the second, and that's in the middle, and then going to the third letter. So to find angle ADB, I start at A, I go down to D, and then to B. So I know that angle ADB is essentially the angle made by following that path from A to D to B, which makes this angle here. So it's telling me that angle ADB is 38, okay? And then I can sort of use that notation all the way through. So it's just giving me the information. It's all on the diagram anyway, so you don't need to stress too much, but it's just good to understand how the notation works. So ADB is 38, BEC is there, is 41, and DAB is 120, which is that. But the important thing to realize here is that we have got a parallelogram. You can see that from the fact that we're told it's a parallelogram, and also from the fact that we've got two sets of arrows. We've got arrows here, so these lines are parallel, and double arrows here, so that these lines are parallel. So we know that they're parallel, so we can use some of those parallel line facts that we've just learned. And which parallel line fact am I going to need to use? I want to find X, but I can't exactly get straight to X straight away. So could you type into the chat for me the name of the angle using this notation, so the 3 letters of the angle I should find before I can find X? Which one can I find? I've got ADC, brilliant. Yeah, I've got ADC, I'm being told here. So go from A to D to C. I can find this angle, can't I? Because I know that those 2 angles are inside parallel lines. So they are, and if I was asked to give, I have been asked to give reasons for my answer. That is where that word co-interior or allied would be important. So I would not just write down what the angle is, but I write down the reason for that as well, okay? So I would write down here, this would be my working. I'm going to get black pen because we're not allowed to use red pens in our exams, are we? I'd write down angle ADC equals, now what does angle ADC equal? Who can write that down in the chat? We've got to actually do some maths. So we haven't done a huge amount of maths yet today. We've just been doing lots of vocab. What's it equal to? Remember the rule about co-interior angles? Use that rule. Almost. Try again. I'm looking for this angle ADC. So I know this one is 120. What's this whole angle here? So essentially, I've got that. I've got parallel lines. I know this is 120. What is this? Oh, brilliant. We've got 60. Okay, it's inside the parallel lines, so they add up to 180 degrees. So I have to do 180 minus 120, which is 60 degrees. Okay, so that would get me 1 mark. And then the second mark would come from writing down co-interior angles, sorry, add to 180. So you want to write that sentence down as well. Okay, so in your exam, those first few marks, and this question would be probably worth 5 marks. In fact, 5 marks this question in a past paper. So your first 2 marks here, 60 co-interior angles add up to 180. There you go. Okay. Now that helps us because we know that, but does it help us because we actually want to find x? Okay, so it doesn't help us that much because we need to now find this angle here, which I can call EDC, or I could call it BDC. How am I going to find that angle? Now that I know that this whole thing is 60, how am I going to find this? I have a feeling that some of you have gone straight to the answer in the, oh, close. So if you want to tell me what that angle is or tell me how I'm going to find it, pop it in the chat, have a go. Honestly, it's just good to try things. Think about what we know. We know this is 60. This is less than that, so it's going to be smaller than 60. But we already know that this much of it is 38. So how am I going to get from 60 to this? What do I need to do with that 38? Brilliant, well done. So the next thing I'm going to write down is angle, and it doesn't matter, I could call it EDC or BDC. BDC is equal to, now I know that all of that angle is 60, but I don't want this bit here, so I'm going to take away that 38, okay, and that is 22. And I'm not going to put a reason down for that because I don't have any technical vocabulary. I've just used the fact that that plus that is 60, okay? So I've got that, that's 22. One other thing that you should do in your exam is you should fill in angles as you go. You can write on the diagram, you can fill in those angles on the diagram, it's okay. And it will really help you to see. So I'm getting closer to X, okay? Because I now know what that is. What else can I find? What other angle can I find that will help me get to X? Yeah, brilliant. Okay, this angle at E here. So this angle DEC. Okay, so I'm going to use the good old fashioned what rule. How am I going to find that? Okay, yeah, DEC, well done. So finding that angle. Now they are on a straight line. So what am I going to do to find angle DEC? Oh, December, that's for tomorrow. Brilliant, 180 minus 41 is going to be that angle there. Who's going to do that maths for me? $139, thank you very much. Great, okay, so that angle is 139, and we can finally get to angle X now, okay? We can work out what angle X is. I should be given my reasons. I've not left myself a lot of space. There's a lot more writing than I was ready for. There we go. That's the wonderful thing about writing on screens. You can just move it around. Okay, so there I do have to give a reason, and I'm going to write angles on straight line. Wonderful thing about maths is that you don't have to write in full sentences. You can literally just write those words add to 180. You don't get marked. You don't get marked when you're giving, lovely long full sentences, but you do have to give the keywords. So the keywords will be angle, straight line, 180. That's important. And then finally, we can actually find X is going to be equal to excellent, well done, great. So 180 minus, because they're in a triangle, so we're going to subtract those other two angles away. So minus 39 minus 22, and that gives us the answer 19 degrees. Okay, or minus 139, I should have said. So quite a lot to do in that question. But the important thing that I wanted you to kind of see is, sorry it's so messy, but how to set out questions like this. So you need to really clearly show which bit you're working on. So you can actually write down angle this is equal to that. And you need to give your reasons, okay? You never get full marks on a question like this if it says you must give reasons and you're not writing down how you know. In fact, I probably wouldn't get full marks for this because I've not written here. I've not given a reason for this one. This one I used the angle triangle. If you're in a rush, you don't need to write the full thing. You just need to write angle, triangle, equal 180. Bam, you've got that mark. Okay, so if you're thinking, oh, the time's running out, just write that down like that to get that mark. Okay, so giving your reasons is really important. So I've given 3 reasons there, and I probably, and a mark scheme may well say, if you don't give all 3 reasons, you won't get the full marks. Okay, you'd probably get 4 marks, but you wouldn't get 5 marks. So just to be aware of that. Any questions on that? I've gone through quite a lot and I've not given you any time to ask questions. So please ask questions. Shaking heads. Pop it in the chat if you've got any questions. Give me a second. No. Okay. All right, then I will move on. So we haven't done angles and polygons yet. So I'm going to move on to, I'm going to move on to angles and polygons. We can come back and do this. Just a second. I'm sorry. I'm just having a technical glitch. Find angles and polygons. If we've got time at the end, we'll go back and do that. But I wanted to talk a little bit about polygons first, because it's always too much information, isn't it? Like so much to learn in the maths curriculum. Right, here we go. Let me reshare this with you. Okay, so what is a polygon? Can you see the screen okay? Hopefully you can. Good. Okay, so a polygon is I thought it was going to come up with the answer, but it didn't. A many-sided shape, okay? So any shape, 2D shape that is basically straight lines. It has to be a straight-sided shape, okay? So all of these are names of polygons. Hopefully you know them. 3-sided shape is a triangle. What's the name for a 4-sided shape? It's a quadrilateral. There are lots of different types of quadrilaterals. We've talked about parallelograms today. We know square, we know rectangle, we know trapezium, kite, rhombus. All of those you need to learn, okay? So you need to know the names of them. But generally, a 4-sided shape is called a quadrilateral, okay? So that's a 4-sided polygon. 5-sided polygon. Type it in the chat if you want. So I'm going to move quite quickly though, because I want to get onto their angles. So 5 is a pentagon. 6 is a hexagon. 7 is a heptagon. Okay. 8 is an octagon. Everyone knows that one. 9 is a nonagon. And 10 is a decagon. Okay. So you should learn those names. 12 is a dodecagon. I think you might need to know that one as well, actually. Otherwise they will tell you. So if it's like a 24-sided polygon, they will tell you it's a 24-sided polygon. I don't know what the special name is for that. I don't know if there is a special name. But those are the names that you should learn. So do commit those to memory. Lots of vocabulary today, isn't it? What are polygons? There we go. They are straight-sided shapes. Okay. Here is one. So a polygon is a 2D shape. That just means it's in 2 dimensions. Made when any line segment encloses, they meet each other and they enclose a region. That's a technical name, but basically it's just a shape. All right. The sides and then the vertices, the corners are vertices. Now, when 2 sides, 2 line segments meet at a corner, they form an angle. Okay, so mathematicians are very interested in angles in polygons. They find them very interesting. 2D stands for 2-dimensional. 2 dimensions are length and width. Okay, so there's no thickness, just like a piece of paper, essentially. Okay, so we're going to talk about the angles, but first of all, a bit more vocab today. A regular polygon. If you see the word regular, and you will lots in your maths exams, it means all of the sides and all of the angles are equal. Regular polygons are quite easy because all of the sides and all of the angles are equal, okay? So if I can just work out what one of those angles is, I know that they're all the same, which is nice, okay? Irregular polygon, so they have different size. They may well have one or two or even three angles at the same, but they don't have all angles the same, okay? And then you've got convex polygons where they're all like this. There's no kind of in part, so they're all like, all the angles are less than 180 essentially. And then concave polygons where you've got one angle that goes like that, so it goes inwards like that, okay? So you may see these. The wonderful thing about those questions is that there's only really one type of exam question that they can ask you with these, which we'll show you later, whereas there are a lot more types of exam questions they can ask you with these regular polygons. So let's have a talk about interior angles. Now, interior angles are the angles inside a polygon, okay? That's why they're called interior, because they're inside. So A, B, and C here are interior angles of a triangle. And you should know this sentence. The sum of the interior angles of a triangle is 180 degrees, okay? Been using that a lot today. And that's really important for the rest of this lesson because if I want to work out the sum of interior angles in a quadrilateral, which hopefully you know is 360, you can actually imagine dividing it into two triangles. So we can say, well, there's 180 degrees in there, and there's 180 degrees in there, okay? Now, if I know that there's 180 degrees in there and 180 degrees in there, then the total must be 360 because 180 plus 180 is 360. So we can pretty much work out angles in a polygon using this 180 rule, or how many triangles can you fit in a polygon. There was a big thing on Twitter, I think it was on Twitter earlier this week, where they got, I think 100 parents or a big group of parents to try a GCSE maths question. And it was based around this concept of splitting polygons into triangles and then working out the angles. And they said something like 100% of parents couldn't do it or something. So it was obviously quite a tricky one, but that was just an interesting article I read earlier. So it was based around this concept of taking a polygon and seeing how many triangles fit into it and understanding that they are 180 each. So we can use that then to build up, how many triangles can a pentagon be divided into? Well, a pentagon can be divided into 3 triangles. A hexagon can be divided into 4 triangles, and so on. I'm sorry I'm going quite quickly because I just want to get to the formula that you need. But the number of triangles that a polygon can be divided into is always 2 less than the number of sides. So you can take the number of sides, you can minus 2, and then you know there are that many triangles. And then you can multiply that by 180 degrees to find the sum of the interior angles in an n-sided polygon. So I'm going to skip this. I'm going to go and do some actual maths with this now. Where are we? Okay, so let's do the sum of the interior angles of these. Okay, so the sum of the interior angles of a triangle, you should know, is 180 degrees. The sum of the interior angles of a quadrilateral, whether it be a square or any other quadrilateral, is 180 times 2, so it's 360. And the sum of interior angles in a pentagon is, we can split it into 3 triangles, so it's going to be 3 times 180 degrees, which is 540 degrees, okay? What about, let's just draw a completely random 7-sided shape. Trying to do a 7 is not that easy. So there's 7 sides, okay? Now I'm going to use that formula that I just talked about. So we're going to take 1, 2, 3, 4, 5, 6, yeah, we've got 7. So we're going to take the number of sides, that's 7, subtract 2 to find the number of triangles, times that by 180 degrees, and that will give us the sum of the angles inside that polygon. So 7 minus 2 is 5. Now remember, because it's in the brackets, we have to do that first. Times 180 degrees. And that is, I believe, 900? Yeah, 900 degrees. Okay. So remember that that tells us the sum of the angles in the polygon. So in regular polygons, and this is where it gets important, all of those angles are the same. So in an equilateral triangle, we've got 180 degrees, and they are all the same. So it's going to be 180 divided by 3, and that gives us 60. So each angle is 60 degrees. Okay. In a regular quadrilateral, and a regular quadrilateral is just a square because it has equal sides and equal angles. Then we've got 4 angles, and the sum of them is 360. So to get each individual angle, we divide that by 4. So 360 degrees divided by 4 is 90. And then in a regular pentagon, we have got the sum of the angles is 540. There's 5 of them, and they're all equal. So each individual angle is going to be 540 divided by 5. Okay, which is 108 degrees. Does anyone want to tell me what each individual angle, let's pretend this is regular. My really bad drawing there, I'm sorry about that. Pretend that's a regular heptagon, 7-sided polygon. What would each individual angle be? Has anyone got their calculator on them that could do that maths for me? So they all add up to 900, and there's 7 of them. It's not a lovely straight. Yeah, good, well done. Okay, rounded up to 1 decimal place is 129 degrees. Okay, it's not a lovely straightforward number. It's actually 900 divided by 7 is equal to 128.5714. So we've just rounded that up to 129 degrees. Okay, and so on. So those are your angles inside the polygons. Gone through that quite quickly. I wanted to just move on and do one. I'm going to do exterior angles next week or next time because I think we've just run out of time. But to find one exam question. Here's a good exam question. So we've got a couple of minutes left. Does anyone have any questions, or do you want to just do this quick? Do this quick? Okay. So we've got the diagram shows a square and 4 regular pentagons. So this is a good question because it's all regular, okay? And we are being asked to find the size of the angle marked X. So we need to know, now in a question like this in an exam, I would highly recommend that you mark on anything you know. So for example, I can see a square. So I'm going to mark straight away on that square these right angles because I know that a square has 4 right angles, okay? So I'm going to put those in. Now, what have I got? I've got 4 regular pentagons. Well, we've just talked about how to find the angles in a regular pentagon. Okay, so angles in a regular pentagon, they are all the same. So I know that that's the same as that, and it's the same as that, and it's the same as that, and it's the same as that. So if I know what the sum of them is, then I can find the individual ones, okay? How do I find the sum of the angles in a regular pentagon? Sum of angles in a regular pentagon. Pentagon has 5 sides. And I've told you that formula, but I'd skipped over it quite quickly. So I'm going to just put sum of angles in an n-sided shape. There is a formula for it. It is the number of sides minus 2 times 180. Okay, so n minus 2. Now a pentagon has 5 sides, so it's going to be equal to 5 minus 2 times 180. So what is the sum of the angles in a regular pentagon, or any pentagon actually? Can someone put that in? Brilliant. Okay, so 540 degrees. So that means these 5 angles equal 540 degrees. Now, I only actually need to know, I've got this one. I only actually need to know this one. So I want to now find each individual angle. And because they are all the same, I can do that. Okay, so one angle in a regular pentagon. So I'm going to want one angle in a regular pentagon there is going to be what? Who can tell me that? I did tell you. Brilliant. Thank you. 540. Divide that by 5 because there's 5 of them is 108 degrees. So that is 108 degrees. There. Okay, so I'm putting that on there. Now, I also need to know what this is. Who can tell me what that is? I think that's gone in the chat. Yeah, 108. Well done. How do I know that? Well, it's a regular pentagon as well. So I found out that the sum of angles in any pentagon is 540, and the sum of angles in any regular pentagon, no matter what size the sides are, it's always going to be, or one individual angle is always going to be 108 degrees. So you can remember these, you can remember the angles, but it's a lot to remember. And working it out is really important because you might be asked to find the interior angle of a regular 52-sided shape, okay? So you can't obviously remember the size of the angles in every regular polygon. So using that method is really important. But you can definitely remember like triangle, regular, an equilateral triangle is 60, a square is 90, pentagon is 108, okay? Hexagon is 120. I believe, okay, and so on. Anyway, let's do this last bit of math. So we have got that these are 108, 108. A right angle is 90 degrees. How am I going to find x? Last bit of maths before we get to go and enjoy your evenings. Feel like I'm back in the classroom. You have to get the answer right and then you can go and enjoy your evening. Brilliant. Okay. So I've just realized that I actually also need to calculate the answer there rather than just waiting for you to do it. Brilliant. You got it right. Well done, Meadow. Fantastic. So I'm just going to show you how that 54 degrees came about there. So we have got these angles are all at a point. Okay, we've got X there. Then we've got this one that we worked out to be 108. This one kind of, well, like that we worked out to be 108. Ooh, 108, 108. And then this one was 90. So those all add up to 360. They are angles at a point. So then we can do 360 minus 108 minus 108 minus 90, and your calculator should do that all for you. Or if you're feeling extra good today, you can do that in your head and you should get 54 degrees. Well done, Meadow. Well done, Tabitha. Brilliant. Okay, so a couple of exams questions done today. I hope you're feeling confident with that. We're going to build on that next week. We're going to practice developing some algebra into these style questions. We're going to do exterior angles in polygons, and we're going to do some more exam style questions as well. Okay, so any questions before you go?